Chapter 2.2 Systems of Linear Equations. Two equations make up a system. There are three different methods that you could use to solve a system of linear equations. One method is graphing. The other two methods are algebraic type solutions of elimination method and substitution method. No matter which one of these methods you use, there are three possible kinds of solutions that result from these methods. No solution, one solution, or infinitely many solutions. This video is going to explain and help us understand the graphing method. On page 64 in your textbook, the three methods are shown. The center column is the graphing method. I'm going to just summarize that here for us. Remember, there are possibly three types of solutions. One solution would be absolutely no solutions found, meaning you're going to go ahead and graph the two equations, each line representing an equation, and you notice here that they are parallel lines when you graph them. We will not be able to find one point on a line that represents both of these. They will never intersect and they will never touch each other. Therefore, there's no solution. The slopes, m equals m, are exactly the same because they're parallel. Point of intersection, b, are not equal. Picture that there's an x-axis and a y-axis, and both of these lines cross at different places on the y-axis. Now, the second type of possible solution you may encounter is where you'll have only one solution. You're going to, again, graph the two equations and get two lines. And in this case, they will actually cross at one place. So this point, this xy value, this ordered pair, will be on one equation and also will be within the other equation. And that's called the point of intersection. That one point will be on both lines. That's called one point of intersection. Notice the slopes are not equal. You can just look at this and see that the slopes are not equal. So far we have parallel lines, no solution, slopes are the same. We have one solution where the lines cross, point of intersection, slopes are not the same. And our third type of solution is infinitely many solutions. You're going to be given two equations. They will be exactly the same. And they will overlap each other, or as we say, they will coinciding lines. Every point on one line is the same on the other line because they're exactly laying on top of each other. Now, if you notice, the slopes here will be the same. Oh, yes, of course, everything has to be the same. Even their points of intersection where they cross the y-axis. So, to summarize again, just make sure you understand and can remember. No solution, one solution, many solutions. Notice the slopes. Parallel, the slopes, you can just look at it and see that they're the same. Here, the one solution, you can see definitely they're not the same. And the last type, infinitely many solutions, you can just see that the slopes are the same because every point is the same. In order to graph the two equations that make up the system, they must be in the slope-intercept form y equals mx plus b. If they're not in this form, then you have to rewrite each equation to be in the form y equals mx plus b, because this is the way you're going to enter them on your calculator. Before you start graphing, I'd like you to see what the slope and y-intercept can tell you prior to your graphing. Let's take an example. We have two equations. We have y equals 9x plus 1, and that is in the correct format, y equals mx plus b. The second equation, y minus 1 equals 9x, the y is not alone. We have to add 1 to both sides to get the right slope-intercept form. So we have now y equals 9x plus 1. Well, wait a minute. If you notice, they're both exactly the same. And remember, when they're exactly the same, your two lines are going to graph exactly one on top of each other, and that means that everything is the same, and you're going to have an infinitely many number of solutions. Well, if by chance you didn't remember that, look at the slope. The slopes are the same. Now think of the three solutions. The slope being the same, they could be parallel, or they could be infinitely many, one on top of each other. So let's further look at the intercept. They're the same. So that means slope and intercept are the same. And in that case, they are overlapping lines. The lines are the same, and there are infinitely many solutions. Let's take another example. Y equals 1/7 x plus 2 and y equals 1/7 x minus 9. And notice they both are in the proper y equals mx plus b format. All right, taking a look at both the lines, first you can see that they're not exactly the same. The slope is, but not the y-intercept. So since they're not exactly the same, we can totally rule out that they are going to have many, many, infinitely many solutions. That's because they're not going to overlap each other. They're not the same. So what we have left is one solution where the lines cross to get one point of intersection, or we have no solutions. The lines are parallel. Let's take a look at the slope. The slopes are the same. If the slopes are the same, they have to be parallel, and the y-intercepts are not the same. But mainly the slopes being the same at this point tells you that the lines are parallel. Same slope and different y-intercept. Therefore, lines are parallel, and since they are parallel, there will be no solution. There is absolutely no point of intersection. One last example. If you notice, both equations are in the correct format, y equals mx plus b. Now take a look at their slopes. Their slopes are not the same. One slope here is a -1, the other is a +1. Therefore, you know that it has one solution and the lines will intersect at one place. Now, how do I know that right off the bat? There are only three possible solutions. Parallel lines, pictured in your head, parallel lines, they have the same slope. Overlapping lines, one on top of each other, the same equation, they have to have the same slope. Well, the last and the third solution here does not have the same slope, and therefore they must be the intersecting lines. And what we're going to do is after you graph this, you're going to go ahead further with graphing and using your calculator, and you're going to be able to find that one point of intersection, that one solution. You must graph to find that solution, that point of intersection. We talked about one of the possible solutions is to graph the two equations, see that they cross at one point of intersection, and then go ahead and use a method to find that point of intersection. Now these directions are the directions that you're going to find in your textbook on page 68, the bottom of page 68. They will explain this verbally, and they will even show you an example on the page. Now, what I'm going to do is I've made a video titled Texas Instrument Graph and Calculator Solve a System of Linear Equations, Find the Point of Intersection. It will show you logically how to do this, and you will probably not need to remember all these directions. The only thing you'll probably have to remember is to press the second key and then the trace, the calculate. I'd really like you to go over and watch this video, find the point of intersection. right after looking at this. You don't have to copy these instructions down. You're going to see. If you need them, you can come back to them. They're also in the textbook. But I think watching the video will help you do this. This is the end of the video.